Today, I learned about how we can detect bias in dataset, especially medical data. We are currently in a world where AI is taking over and AI algorithms are mostly biased. However, most people in charge of training these AI models don't even realize that the data is coming all the way from the data sets they are feeding these models. So we want to be able to identify especially social biases in dataset and prevent this problem from the foundation. So I learned about the data level bias metrics and the algorithm bias level metrics that we can evaluate in dataset. First one is statistical parity difference, which is sort of checking if privileged groups are receiving favorable outcomes better than the unprivileged groups. For example, are white people getting lower healthcare expenses compared to black people, compared to Asian? Then we have class imbalance, which we go over your data set and have the ratio of different groups in your data, the ratio of white to black to whatever, the ratio of female to male, or the ratio of Hispanic to non-Hispanic, and it will flag if a particular group is represented less than 10% in your data set. And then we have poor opportunity difference, which is checking if a particular group is getting better opportunities compared to other groups. So went into the algorithmic level biases, which employed lazy predict to sort of run over several ML algorithms like random forest, support vector machine, Gaussian MB, many of these algorithms, and get the accuracy, get the AUC score, get the F1 score, and performs fairness versus accuracy trade-offs. For example, if your ML model is predicting most black people as having high healthcare expenses, for example, while your true level is saying something completely different, you can flag this as a bias from the machine learning model. Or when your machine learning model has 90% accuracy or about 20% statistical parity difference, you would rather go for a machine learning model with lesser accuracy but better SPD score. We also did this for neural network models, a simple neural network, a deep neural network, and a residual neural network, ResNet. We were able to calculate the fairness and bias levels. That's it for today. See you tomorrow.